Mhm. Hi, my name is Durga Prasad from UP second year, UP BQ 580409. We are talking about the seminar on random process. Now we are converting random process into classification, deterministic and non-deterministic random process. First one is what is random process? The random process is also called a stochastic process. So the random process consists of collection of random variables in the time domain or space domain, anything. For example, a random process is a family of random variables is equal to x of 1, x of 2, x of 3, that like this. When each x of t represents the value of the process of t at time t and values in certain conditions. The each value of x1, x2, x3, er shows the what is the value in the specific time in the time domain. Now some examples of the random process. What are they? Atmospheric noise, stock market variations, temperature changes, and etc. Why these are examples? These are vary by the time. We cannot determine what is the next value of the output. Classification of random process. We can classify the random process based on disk time and random process voltage like that. And random process can be categorized based on whether time and amplitude voltage of a random variable are continuous or discrete. Accordingly, divided in four types. By continuous and discrete of a random variables, we can divide it into four types. And first one is continuous random process. In continuous random process, the time is continuous. Time is continuous. And voltage is also continuous signal. This is a can determine the next value in the signal. This is a noise signal. You can't determine the next value. That means it is a random signal. It is normal signal. In continuous signal, the time is continuous and the amplitude voltage is also continuous in continuous random process. And the next one is discrete random process. What is the example of continuous random process like noise, normal voltage signals, etc. In discrete continuous random process. In this process, the time is constant. Sorry, time is discrete form. The continuous amplitude and discrete time. Discrete amplitude is specific value only. That means discrete. The the time is discrete, voltage is continuous. This is a normal 0 1 signals of digital signals 0 1 0 1. This is 1, this is 0 1 0, etc. This discrete time random process is nothing but a digital signals. Now next one is continuous random sequence. Sequence is nothing but the time is in discrete format. Linear random sequence, the time is discrete format by changing amplitude in discrete or anything. In continuous random sequence, the voltage that means the amplitude is continuous. See in this figure, the amplitude continuously changes. But what is the time value? Time value is fixed. Time value is discrete time value. In continuous random sequence, for example, we have this side. This is a discrete time, making samples. Samples of a given signal. That the samples of given signal. In this continuous random sequence, the T is continuous. T is discrete. Sorry, T is discrete format and amplitude A is continuous format. The next one is discrete random sequence. In discrete random sequence, we have a discrete signal. We have a discrete signal. In the discrete signal, more normally the discrete signal has a continuous time, and in this we have a continuous voltage also. These are the samples. What are these? We have a samples like this. In the signal, we have samples like this. 1. These samples are come to 1. These samples are 0. Only these samples are 1. See, it is like a discrete format. In the discrete format, 0, 1, 0, 1. And amplitude is continuous discrete. Time is also discrete. These are the sample signal of a normal signal. We can assign the values. We can assign the voltage values to this discrete random sequence. This is called quantization levels. This is called sampling. When you apply the voltage level to the sampled output, this is called a quantization level. That means you can apply voltage level to these samples. And the next one is what we are talking about, this continuous random sequence, discrete random sequence, continuous random signal, discrete random signal. In random signal, the time is, the voltage value is continuous. In discrete random sequence, the time is discrete. In sequence, time is discrete. Now we are talking about the deterministic process. In the deterministic process, we can determine the what is the next value. For example, we have a like a sine wave like this. This is 0, pi, 2 pi. You can determine, if we have a 0 to pi signal, we can determine the next signal is pi to 2 pi. And what is the next signal? 0 to 2 pi to 3 pi. That's like this. We can determine the what is the next value of the signal. And the next one is non-deterministic signal. In this non-deterministic signal, we can't determine what is the next value of the signal. For example, we have a noise like this. We have a noise like this. This is the noise of the signal. What is this? This is normal. We applied signal. We transmitted signal is sine signal. The noise is occurs in the channel. Now we want to remove the noise from this. This noise is applied in the voltage value, upper voltage values of the this noise is added higher voltage levels of the signal like this. Now we want to now remove this noise. How can we remove this noise? We don't know what is the next value. If it is a 1, and the next value becomes 3. We can't determine. And what is next value? The next value becomes 5. And the next value becomes 7 or 8. You can't determine what is the next value of the signal. This is called a non-deterministic signal. For example, what is noise? And second is weather variations. The weather varies on day by day, time by time. You can't determine what is the tomorrow's weather. The weather is variation. So we are not determine the what is the weather of the tomorrow. And stock market levels. Yes. What is the next value? What is the stock market? In the stock market, the values increases at the same time it decreases, and again it increases. We don't know when it is decreases and when it is increases. These type of signals are called a non-deterministic signals. Summary: what we are talking about with this lecture: random process. Random process concept. What is random process? The random process is a group of random variables in specific time. These are called a random process. And classification of random process. We have whatever we have classification. First one is the continuous random signal, discrete random signal, continuous random sequence, discrete random sequence. These are the classifications of the random process. And next one is deterministic signal and non-deterministic signal. What is the difference? Deterministic, we can determine the next value. In non-deterministic, we can't determine the next value. This is all about this lecture. Thank you.